Okay, we have this vector 5, 10. And remember, the vector tells us it's a type of movement, right? It's not actually a line segment. We want to think of it as a movement in the coordinate plane, and that movement has a direction and a length. When we want to sort of picture it, we would draw it as a directed line segment with a little arrow at the end to tell us we're headed in this direction and we started at the origin. This is just a picture of what this would look like, right? If we start at the origin, this is where we would end up. Right? But this vector could start or end anywhere. It's just a movement. It's an amount of change. And we're asked to find the components of a vector that is 2/5 as long as this one. And I guess we don't necessarily have to have it point in any particular direction. We're just trying to find one that has a length that's 2/5 this. But let's just make it easy on ourselves and have it point in the same direction. So what we could do is we could just take this, and I'm going to break this down into 1/5 size pieces, and then I'll just take 2 of them. So let's see. We travel to the right 5. So that's 1, 2, 3, 4, 5. And we travel up 10. So if we want to break 10 down into 5 steps, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then, to travel this entire distance in 5 steps is over 1 up 2, over 1 up 2, over 1 up 2, over 1 up 2, and over 1 up 2. So now I have this vector broken down into 5 smaller pieces, fifths. And so now if I want to travel, there's 1/5 of the length, there's 2/5 of the length, 3/5, 4/5, 5/5, right? So 2/5 would be easy right here. So that vector would be 2 and 4. Okay. Now let's say though that this wasn't so easy to break down, or if the vector was really big and difficult to graph. We could do it simply with the vector and its components itself and no graph. And let's just pick another example to do that. Let's say we had, I don't know, let's pick something random, 34, comma, I don't know, 16. Just making something up there. And we're trying to find a vector that is, oh, I don't know, 2/3. 2/3 of its length. Well, remember, if we wanted to find a vector that was twice as long, I would just double the coordinates, or 3 times as long, or not coordinates, components. Or if it was 3 times as long, I would just triple the components. Imagine here, if I'd started with this vector, right? This vector is just 1, 2, right? If I want to find a vector that's twice as long, I just double the components, 2, 4. 3 times as long, triple the components, 3, 6, and so on. Well, the same thing if I want to find a vector that's 2/3 as long, I just multiply the coordinates by 2/3. And we actually could write this with the 2/3 outside like that, remember from an earlier exercise, and then we just kind of multiply it into the vector. So our new vector would be 2/3 times 34, and 2/3 times 16. So let's see here, 2/3 times 34, 2ABC3 times 34 gives us 22 and 2/3. Let's see what that is. That's 68/3. And 2/3 times 16, 2ABC3 times 16 is 10 and 2/3. That's 32/3. And there's our new vector, which is 2/3 as long as the original. Now, a couple comments about this. One is that you need to use your fraction calculator unless you're really good with fractions, okay? And even I use it because it's easier. You don't want to round these off. You do not want to put in 68 divided by 3 is 2.6, right? That's not going to be good. You want to have exact values. You got to leave them as fractions. And also, we want to have them as improper fractions. It gets confusing when you start to use mixed numbers because they look a little like multiplication, like 2 and 2/3 is 2 2/3, but it could be possibly confused as 2 times 2/3, possibly. So we want to avoid that. We just want to use these improper fractions, and the calculator will do that for you. If you have a 2 ABC 5/9, right? It's 2 5/9, but I just press second and the ABC button and enter, and that's going to turn it into that improper fraction again. And so again, if you're trying to find a vector that's some fraction of a length of a larger vector, all I do is take the two components of that vector and multiply it by the fraction. And then I will get my new vector.